An extraordinary cosmic spectacle is unfolding, captivating stargazers around the globe. Betelgeuse, the mesmerizing red supergiant that adorns the shoulder of Orion, is undergoing a significant transformation. This celestial giant, known for its brilliant red hue, has been a constant in the winter sky for centuries, inspiring awe and wonder from ancient civilizations to modern astronomers. What makes this transformation so remarkable is not just the changes occurring within the star itself, but the immense scale and speed at which these changes are happening. This enormous star, many times the size of our Sun, is demonstrating just how dynamic and unpredictable the universe can be. Betelgeuse's glow, the brilliant shine that defines its celestial presence, has surged to a staggering new level, increasing in brightness by a remarkable 50%. Imagine a light suddenly doubling in brightness, casting its glow further and more powerfully. That is exactly what is happening with Betelgeuse on a cosmic scale. At the start of this year, Betelgeuse proudly held the title of the 10th brightest star in the night sky. Its steady, recognizable light was a constant, a beacon of stability. However, this sudden increase in brightness has propelled it to an impressive new ranking, now shining as the 7th brightest star in the sky. This dramatic shift has sparked excitement and curiosity within the astronomical community, leading to new observations and studies aimed at understanding the mechanisms behind this extraordinary change. As an enormous star nearing the end of its life, Betelgeuse's size is truly mind-boggling. If it were located at the center of our solar system, its outer layers would extend all the way to the orbit of Jupiter. Eventually, this star will collapse, culminating in a massive supernova explosion, which may result in the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's eventual supernova stems from the fact that it will be an unparalleled event, visible from Earth as a spectacular display of light. Positioned about 650 light-years away, humanity finds itself in the perfect spot to witness this cosmic event firsthand. When the supernova occurs, it will unleash a dazzling burst of light. Initially, a flood of neutrinos will sweep across the Earth, detectable by observatories worldwide. Following this, high-energy photons will escape from the expanding cloud of cosmic debris. Betelgeuse will rapidly increase in brightness over the course of 7 days, potentially reaching up to 100,000 times its normal luminosity. Depending on the strength of the explosion, this celestial beacon could rival the brightness of a full moon and might even be visible during daylight, casting distinct shadows on Earth. This grand event will last for a prolonged period, offering astronomers an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While the impending supernova of Betelgeuse may evoke fear and speculation due to its historical association with ominous signs, we can take comfort in knowing that we are situated at a safe distance, far from any harmful effects. This gives us the freedom to fully appreciate the mystery surrounding Betelgeuse. To understand the significance of these changes, it's crucial to look back to late 2019, when strange phenomena began to emerge. During this period, Betelgeuse, the red supergiant, began experiencing substantial dimming, a change observable even with the naked eye. Observations made with advanced telescopes in the optical range revealed that, while Betelgeuse appeared largely stable, its photosphere, the outer layer where light is emitted, showed signs of major disturbance. The photosphere was expanding, making it appear as if the star was growing larger when viewed from Earth. This expansion continued steadily at a rate of around 8 kilometers per second for most of the year, until mid-November 2019, when the outward movement began to slow. By that time, the outflow of material from Betelgeuse had stopped, prompting astronomers to capture new optical images of the star. These new observations revealed two surprising anomalies. First, a dark region appeared on the star's southern hemisphere, contrasting sharply with earlier images from the beginning of the year. Secondly, the star's surface temperature experienced a dramatic drop, cooling by about 80 Kelvin between January 27 and February 13, 2020. During this period, Betelgeuse's brightness reached an unprecedented low. However, over the following months, the star gradually regained its brightness, eventually returning to its typical magnitude. This prompted astronomers to ask, what exactly happened to Betelgeuse? The available evidence strongly suggested that Betelgeuse had undergone a rare and extreme event known as a surface mass ejection, SME. This phenomenon is similar to the coronal mass ejections, CMEs, observed on the Sun. To understand an SME, imagine a volcanic eruption on a scale comparable to that of a star. Material from the star's interior erupts outward, causing shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SME resulted in the release of a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs. This mass, which was many times the size of the Moon, traveled at remarkable speeds. Scientists noted that such a massive release of material from a star's surface had never been observed before. The event allowed for direct observation and analysis of the star's surface features using the Hubble Space Telescope, providing a rare opportunity to study the aging and evolution of a dying star. The SME had a significant impact on Betelgeuse, causing it to lose a considerable amount of mass in a single event. This demonstrated how a dying star could experience massive mass loss beyond its typical yearly reduction due to the stellar wind. It was as though Betelgeuse had violently expelled its outer layers and was now in the process of slowly recovering from the aftermath of this event. Following this dimming event, the star's behavior began to change. Previously, Betelgeuse would oscillate in brightness roughly every 400 days, a pattern believed to be caused by pulsations in its core. However, after the SME, the star's oscillations became more irregular, with its brightness fluctuating every 6 months. Betelgeuse is classified as a semi-regular variable star, meaning it experiences varying periods of brightness due to changes in its size and temperature. Scientists used computer simulations to gain a deeper understanding of these events, offering valuable insights into the complex processes occurring within Betelgeuse as it nears the end of its life. Betelgeuse's behavior has been especially noteworthy due to its unpredictability and variability, which have provided crucial insights into the later stages of massive star evolution. Initially, its fluctuations were thought to follow a predictable pattern, but recent changes in its pulsation periods and sudden dimming events have surprised astronomers. One of the most significant observations in recent years was the dimming event that began in late 2019 and continued into mid-2020. This dramatic decrease in brightness caught researchers off guard, as the star lost a substantial amount of its normal luminosity. The dimming was not only visible to the naked eye but also detectable through precise measurements with advanced telescopes. Such events are rare for a star of Betelgeuse's size, prompting intense studies to understand their underlying causes. Several theories have been proposed to explain the dimming episodes. One prominent hypothesis suggests that the dimming may be linked to the release of material from the star's surface, possibly triggered by convective cycles deep within its interior. These convective cycles, similar to giant bubbles of hot gas rising through the star's layers, can disrupt its regular pulsation and lead to the ejection of stellar material into space. While such events, known as surface mass ejections (SMEs), are common in stars, the scale and impact observed in Betelgeuse's case make it an unusual and intriguing subject for study. The aftermath of Betelgeuse's dimming has also been a major focus for astronomers. They have observed changes in the star's pulsation pattern, with its regular 400-day cycle being disrupted and replaced by a shorter 200-day cycle. This shift suggests significant internal changes within Betelgeuse, possibly signaling impending dangers that could lead to dramatic events such as a supernova. Supernovae are among the most powerful phenomena in the universe, marking the end of a massive star's life in a spectacular display of light and energy. While Betelgeuse's recent behavior has spurred speculation about a potential supernova, astronomers caution that predicting such events with certainty remains difficult. The timing of a supernova largely depends on internal cycles within the star, including the fusion of heavier elements in its core and its subsequent collapse under its own gravity. Betelgeuse, estimated to be around 8 to 8.5 million years old, is currently in the final stages of its evolution. Having exhausted its hydrogen fuel, it has shifted to fusing helium in its core, a process that will continue until heavier elements are formed, eventually leading to the creation of iron. The accumulation of iron in Betelgeuse's core will signal the end of stable nuclear fusion, triggering a catastrophic collapse and potentially a supernova. Should Betelgeuse go supernova, its proximity to Earth, about 650 light-years away, would make it a breathtaking celestial event visible across the entire solar system. A supernova from Betelgeuse would briefly outshine the entire night sky, casting shadows on Earth and producing detectable signals of neutrinos and high-energy photons across the universe. The study of Betelgeuse's future and the potential for a supernova is not only a scientific endeavor but also a cultural and historical curiosity. Supernovae have been observed and recorded throughout human history, often leaving a lasting impact on civilizations through their appearances in myths, legends, and historical records. For example, the famous supernova of 1054, which resulted in the Crab Nebula, was observed and recorded by Chinese astronomers and has since been extensively studied by modern scientists. Advancements in observational astronomy now allow scientists to monitor Betelgeuse with remarkable detail. Telescopes like the Hubble Space Telescope, along with ground-based observatories, provide real-time observations of the star's variability, helping researchers refine their models and predictions for its future evolution. Beyond its scientific significance, Betelgeuse also holds cultural and symbolic importance across various human societies. Its name, derived from Arabic roots, has been interpreted in different ways throughout history, often associated with human body parts in ancient Arab astronomy, reflecting early views of celestial objects. Betelgeuse's prominence in the night sky has inspired stories, art, and philosophical reflections on the nature of stars and their place in the universe. Looking forward, astronomers will continue to closely monitor Betelgeuse, watching for further changes in its brightness, pulsation, and structure. The star's evolution offers a rare opportunity to witness firsthand the processes that govern massive stars as they near the end of their lives. Every observation and discovery adds to our understanding of stellar evolution, supernova physics, and the broader implications for the fate of stars and planets in the universe. As technological advancements improve and new generations of telescopes come online, astronomers will gain even deeper insights into Betelgeuse's behavior and its eventual fate, whether it undergoes a supernova soon or continues to surprise us with its variability. Betelgeuse remains a captivating subject of study, serving as a testament to the dynamic and ever-changing nature of the universe. Astronomers have recently observed a curious event where a hot gas bubble, resembling a massive air pocket, emerged from within the star Betelgeuse. This occurrence is linked to the violent and convective activity within the star's outer layers, much like a pot of bubbling soup where the material is in constant motion and mixing. As this hot gas pocket rose and broke through the star's surface, it triggered the release of stellar material. Strangely, this event also disturbed the star's regular pulsation pattern. The surface of Betelgeuse expanded, while deeper layers contracted, causing the star's pulsation period to shift from its usual 400-day cycle to a shorter 200-day period. Astronomers believe that over the next 5 to 10 years, the star's pulsations will gradually stabilize, returning to the normal 400-day rhythm. As for the possibility of a Betelgeuse supernova, scientists estimate it could occur anywhere between 10,000 and 100,000 years from now, depending on factors such as the star's mass, luminosity, size, and age. Researchers suggest that Betelgeuse is currently in the early stages of helium fusion into carbon, and this process will continue with oxygen, silicon, and eventually iron. Once the core collapses under its own gravity, it will trigger a catastrophic explosion. Given that Betelgeuse is 650 light-years away, any supernova event would only become visible to us 650 years later, due to the speed of light, making it unlikely that we will witness the star's explosive end in our lifetime. What makes Betelgeuse unique is that we can actually observe its surface, unlike most other stars. This provides a rare opportunity to study the behavior of massive stars as they age, including events like these incredible mass ejections. Recently, astronomers made another surprising discovery. They observed a star consuming its own planet, located 12,000 light-years away in the constellation Ayla. With its fascinating name and prominent position in the night sky, Betelgeuse has captivated the human imagination for centuries. Beyond its scientific significance, it has influenced popular culture and folklore around the world. The star's name comes from Arabic, originally translated as the armpit of the giant, though some scholars suggest it may refer to a hand or shoulder instead. This association with a body part is reflected in various cultural interpretations, with Betelgeuse often linked to human or animal figures. In ancient Japan, Betelgeuse symbolized a severed limb, while in Brazil, it was associated with a turtle's leg or a caiman's hind leg. In Sanskrit, the star's name means the moist one, linked to the lunar house Ardra in Hindu astrology, which is associated with the storm god Rudra. Throughout history, Betelgeuse has played an important role in cultural practices and customs. In Macedonian traditions, it represented domesticated animals and agricultural life, while in regions like North Baffin Island and the Melville Peninsula, its rising marked the arrival of spring and longer days. Betelgeuse's prominence in the constellation Orion has made it a key cultural symbol. As one of the brightest stars in the sky, it ranks 11th in luminosity and has inspired artists, poets, and filmmakers. Known scientifically as Alpha Orionis, Betelgeuse continues to intrigue both astronomers and enthusiasts with its ongoing transformation and the possibility of a future supernova explosion. Its distinct red hue and unpredictable nature have captured the imagination of cultures around the world for centuries.